Hello everyone, thank you for joining and welcome to another SysKit webinar. For today we have a special guest, our beloved Sean, who will be speaking about SharePoint performance monitoring. But before we start, we should do a short introduction. Sean, can you tell our attendees something about yourself?
Yeah, hello folks. My name is Sean McDonough. I'm the owner and lead bitsmith of Bitstream Foundry. I sort of switch hit. I'm 50% developer, 50% admin, which means I'm 100% confused pretty much all the time. I think my wife would agree with that as well. I'm a big AR, VR junkie. I've got an Oculus Rift and a HoloLens. I didn't start out in IT. I started out as a polymer chemist, working, believe it or not, in a hair care group at Procter & Gamble. Don't judge my current hairstyle as any reflection on that. I'm the CTO for a nonprofit mental health awareness organization that's headed by my wife called schizophreniaoralhistories.com. I do a bunch of mixes around the holidays. I'm a desktop DJ. Other things, I've got a wonderful wife named Tracy, two beautiful children, Brendan and Sabrina, and I love my coffee, and I'm known to eat the occasional donut. So I think that gets me through the bullets.
Okay, thank you, Sean. That's an interesting introduction. So just in case the others were wondering, my name is Silvio. I'm a business development manager at SysKit, and I'll be holding a SysKit monitor demo for you later on.
Great.
So first, let us go through the webinar agenda. So first, I will explain you how you can ask your questions using the GoToWebinar application. After that, Sean will be speaking about our today's topic, SharePoint performance monitoring. Bravo. And that will be followed by, well, a demo where we will present the possibilities SysKit Monitor offers for SharePoint performance. Of course, at the end of the webinar, we'll have the Q&A session where Sean will be answering your questions. I'm sure you can't wait to ask plenty of them. So if you'd like to ask a question using the GoToWebinar application, all you need to do is open the questions chat box and type them in there. Feel free to ask your questions during the entire webinar, and we'll try to answer all of them in our Q&A session. Sean, I believe it's it's your time to shine now, so feel free to take over.
Okay, thanks, Silvio.
No problem.
Let's see. Are you going to pass control over to me?
Did you not receive it? Okay, again. Did you got control?
Yes, I've got it now.
Okay.
Thank you.
Great, no problem.
All right, you see my screen okay?
Yes, I see it.
Excellent. Well, thanks for joining us this afternoon, folks. It's morning time for me. I'm in the Eastern Standard Time Zone here in the United States, so later in the day for you, early for me. But we're going to be talking about SharePoint performance today, performance monitoring in particular. And here's what we'll be covering. We've got some information I want to cover on farm environments at first. We'll spend the bulk of our time on topics 2 and 3, which are tools and monitoring servers, as well as page performance monitoring, which is monitoring from the other side of the cable, if you will. Of course, at the end, as Silvio mentioned, we've got time for questions and answers, hopefully, and I've got a boatload of references. Everything I talk about is covered in some manner in the references at the end of the presentation, so you'll want to get a copy of it if you want to follow up on any of the topics we're addressing today. So without further ado, let's jump right into some qualifications about farm environments. So you notice I said farm and not stamp. Those of you familiar with SharePoint Online will know the difference between a stamp and a farm. You know, we're all used to working in an on-premises environment with SharePoint farms, but stamps are the SharePoint Online equivalent of a farm. They're basically super farms, for lack of a better way to put it, and they are the way that SharePoint Online is managed. The problem with cloud-based operations, though, is we don't have as many options, at least as in the form of administrative options, that we do on premises, primarily because there's a significant surface reduction for monitoring systems in the cloud. One of the benefits of having the cloud is that it becomes someone else's problem to administer that environment. So administrative APIs like backup, performance monitoring, those sorts of APIs are very limited versus what we get on premises. So we can't run tools like performance monitor, developer dashboard, etc. And in short, we can't get at the counters and the logs we need to actually do monitoring. So this presentation, of course, is going to focus on premises, and so we'll bid the cloud adieu, I'll say at this point, and turn our attentions to an on-premises environment. So before we go too far, I want to talk about getting a solid start. Now, when I originally put this presentation together, I had another presentation's worth of material at the beginning that was focused on building environments and good practices around how to set up environments so that you wouldn't run into performance problems. Because the adage, an ounce of prevention is worth a pound of cure, is no more true than when building SharePoint environments. If you can architect your environment properly, get good hardware, lay down a proper software base, operating system, and applications software, you're going to be much better off in the long term. However, many of us don't have that luxury. We often inherit the environments we're working with, and I've certainly been in the position before where I wish I could have started out with the environment and made the call on how it was designed, but thus it was not to be, and so I inherited someone else's problems. But if you are in the position of building a new SharePoint environment and you're speccing out your hardware, deciding what you're going to put in terms of processors and things like that, I won't spend too much time on it. I will say this though. The linchpin of every SharePoint environment from a performance perspective is SQL Server. And there are so many easy ways to make sure you do just simple things for SQL Server that will pay dividends down the road. So a few things to bear in mind if you have the option to either build a new environment or even build out a new SQL Server. First, if you're virtualizing, and that really shouldn't be if these days, it's when. I mean, 5, maybe 10 years ago, it was if people were virtualizing, but nowadays hardware has become so powerful that we virtualize everything. So if you're virtualizing, when you virtualize, minimize abstractions. And what do I mean by that? Well, abstractions in virtualization terms, we often have many different layers stacked underneath the operating system before we actually get down to the hardware. We've got a hypervisor layer, we have virtualization software, we have drivers and redirectors. Minimize as many of those as possible. For instance, with Hyper-V, you can attach storage and pass. You can attach storage directly to VMs and pass through without going through VHDs or VMDKs if you are building out disks. Anything you can do to minimize the amount of translation that's going to happen is going to pay dividends. So minimize abstractions. Choose an appropriate storage subsystem. This is the old argument of, which level of RAID do I want to use? If you are in the process of trying to decide how to spend your storage dollars, I've come across many SharePoint environments where, unfortunately, SQL Server was cobbled together from pieces and parts, and in order to save money, storage was shortchanged. So things like RAID 5 arrays were used for storing data, and especially things like tempdb logs, tempdb logs. That is a horrible, horrible thing to do to your environment if you're trying to maximize performance. RAID 5, of course, is striping with parity. There are calculations that go into every write to that array, and so you're naturally just slowing yourself down by putting that in place. So if you're going to put put drive arrays behind your SQL storage. Choose an appropriate storage subsystem. So get something that's RAID 1 or RAID 10, not RAID 5 for high performance disks. There's plenty of documentation in the resources to explain this on what different levels of RAID are. Don't skimp on the disks. One of the great pieces of advice I read recently in a guide that I'm going to cover here in just a second is placing each of SQL Server's different storage requirements on a separate disk, physical disk, if you can. So temp DBs go on a physical disk, temp logs go on a physical disk, data DBs, and the data logs as well. That sounds like a lot of disks, but really SQL Server is an IO monster. It will eat everything you give it and then ask for more. So don't skimp on your disks. And finally, put your IO where you need it. And that is more around just making sure that you can address the various IO scenarios that SQL Server invokes. Understanding your usage patterns. For instance, if you're in a heavily collaborative environment, you're going to be doing a lot of writing as well as reading. But if you're in an environment where it's more publishing based, maybe a public facing website, it's going to be more read intensive. There are different ways to structure your storage and basically align those different storage drives with the particular usage patterns. So without bumbling any further, one smart investment I will say you should make. This is a great guide. Vlad and Gökhan put a lot of work into this. I picked this up probably a few months ago when it was first released. And it covers everything from provisioning all the way through to monitoring, as well as some performance troubleshooting. But it's oriented entirely around things that you can do to improve performance in your SharePoint environment, as well as build environments brand new that are highly performant. I highly recommend it. This link is something that this is special for this webinar. The guys, I contacted them before this webinar and said, hey, I want to give a shout out for your guide because I think it's so great. So this is a special link. It'll get you 50% off the guide. So it's normally, they ask for $10. It's a sliding scale kind of thing. You can give them more money, but you can get the guide for as little as $5 with this link. So you may want to go out and check it out. It's well worth the money spent. So let's move on to actual tools and monitoring of servers. So why do we monitor performance? I mean, it seems like a pretty basic question, but the reasons that people monitor performance typically fall into one of three categories. We're either seeking to understand why our SharePoint environment is underperforming. It's pretty common. And this often leads to troubleshooting. We're trying to figure out why our web front ends are so slow, or why SQL is just not processing our requests in as little time as we think they should. We want to ensure that we have enough headroom to scale and grow as desired. This is capacity planning, and it's a good activity to engage in, ideally before you need the capacity. It doesn't always happen that way, I understand. I've certainly been in a number of implementations where it was a ready fire aim sort of scenario, and we wish we had done some things at the beginning. But ideally, you ensure that you've got enough headroom to scale and grow. Performance monitoring also comes into play when we want to make improvements in our form. We want to extend our capabilities or add new capabilities to our firm, and we want to make sure that we can add the new workload. So it's related to capacity, but it may be in the form of improvements. But either way, one of these three reasons is typically why we come looking to monitor SharePoint performance. So where should you start? Well, first of all, it's worth taking a step back and thinking about where performance issues originate. Now, most performance issues typically originate in one general subsystem. They may, of course, span more because this is SharePoint. SharePoint does everything its own unique way. Excuse me. But we're typically talking about memory issues, network issues, processor issues, or storage, or some combination of the two, the four. And it comes down to identifying where we've got a problem, what general area, and then digging deeper once we've verified that we are, in fact, encountering a problem in that area. So before we do anything, my recommendation, and this is going to be the recommendation of pretty much everybody who does performance monitoring, is going to be to start monitoring servers over time to gain an understanding of where you start from, so your normal state for the server, what's going on day to day when it isn't stressed, and then when you have a problem, be able to observe changes when that problem occurs. This process is very important. This means you actually start monitoring performance well before you ever encounter a performance problem, because it's critical that we establish a baseline for your environment when it's running normally and not stressed. That baseline serves as a future reference point for pretty much every form of measurement you're going to take in the environment. And without that baseline, all measurements are simply relative to one another. I've been in numerous scenarios where performance monitoring was deemed a nice to have rather than a necessity. And once the environment went live, after some period of time, usage grew and we started to encounter problems. So of course, the very first question that people ask is, well, what's the normal operational level? Well, without a baseline, you can't actually provide a valuable answer to that. You can't meaningfully answer that question. So a baseline is that reference point that you need. And it's worth taking time, just a day or two before you go live, before you flip the switch, to get those measurements, because they will become critically important each day that you go forward. So there are many different tools that we can use to, again, in the name of troubleshooting and performance analysis, we can use. They all work a little differently. You're probably familiar with SharePoint's Farm Health Analyzer, which is hit or miss with its measurements. It's not going to really help you if you're trying to analyze performance issues. The event viewer, of course, is critical when you're trying to troubleshoot problems in your environment. ULS viewer is still alive and well. You can download that. Microsoft finally made it prominent on MSDN. I've got a link for that at the end too, because I know that some people have wanted to go back and get the ULS viewer, and it's been tough to find. Fiddler is a common tool, and that gets us moving towards more development-oriented tools. Developer in the sense that we can benchmark calls to web services as well as page requests. Developer dashboard is still part of SharePoint. We have access to it on premises. That's one great thing that we have over the cloud. In the cloud, you can't access the developer dashboard, but you can certainly do that on premises. And then we have other tools like Wireshark for looking at the network traffic going back and forth between servers and clients, as well as server to server. Disk speed and Crystal Disk Mark, these are tools that are used to benchmark your disks. Disk speed is the replacement for SQL I/O. It's much more capable. I've got a link for that at the end as well. It's very heavily command line based, so you're going to be using all sorts of switches. It's it's a bit of a trick. One thing that I found while I was doing some research into disk speed, because I wanted to naturally leverage it to benchmark some disk I/O on a set of VMs that I'd put together. Crystal Disk Mark is a open source project that was put together. It's actually built on disk speed, but admittedly, I'm a GUI person. I like nice GUIs. I like to be able to click buttons. I believe command lines have their place, and I'll certainly write PowerShell all day long if given the opportunity. But I like a GUI when running an application and trying to get back data. And so Crystal Disk Mark Rack wraps disk speed and allows you to pick, 4 sets of tests you want to run, whether you're running sequential reads and writes, various queues, writing 4K chunks, things like that. It's very useful for that. And again, that's a free download. It's in the Windows Store as well as available as a free download standalone. Since today's focus is going to be on performance monitoring, though, we're really talking about looking at counters. Specific performance counters, in fact, that can help direct further investigation and keep us out of the weeds. Because any of you who have done performance monitoring in any form know that it gets pretty ugly pretty quickly. So how do we view performance counters? Well, perfmon is the tried and true, age-proven tool that many of us use. I don't really like perfmon so much these days. Perfmon is certainly, it does what it needs to do. I always had trouble visualizing perfmon data. I'll typically take it out of graph view and switch it over to kind of a report view to monitor performance counters. Since Windows Server 2008, we have the Windows Resource Monitor. Windows Resource Monitor is like Performance Monitor. However, it provides some built-in visualizations that are scaled appropriately for the type of data they're trying to show. So it's much nicer when you're just trying to one-off. And you can get to the Resource Monitor directly from the command line by typing resmon. You can get to it from the Task Manager view. This is the Resource Monitor link that shows up in the Task Manager. You click on that, it'll take you over. So you've got tabs for CPU, memory, disk, and network, which interestingly enough are the 4 categories that we typically bucket our problems into. So I prefer resmon. Now, of course, I'd be remiss if I didn't mention that there are specialized tools that target the area of performance and performance monitoring that do a much better job of displaying data, gathering it intelligently, collating it, and calling attention to performance issues that may be occurring in your environment. And that's one of the great benefits of tools like SysKit. Monitor SP.kit does a bit of this as well. They call attention. They've got some intelligence built into them, so you're not just looking at numbers. There's some actual context and some actual reference put to those values, and so they're worth their weight in gold many times when we're trying to troubleshoot. Let's see here. Okay. So let's do some performance counter basics. So your operating system exposes counters. And like we were talking about, there's counters for network, counters for CPU, counters for memory. There are many, many, many different categories of performance counters. Applications oftentimes expose their own counters. Now, I told you I've switch hit as a developer. I've written many Windows services, and some of those services were used in high throughput environments. So proper instrumentation in my application was necessary. So I, as a developer, would write counters for my application. SharePoint alone exposes over 20 different categories. And in those categories, there are hundreds of counters just for SharePoint. SharePoint is but one application on your system. So as you can imagine, this gets pretty massive pretty quickly. The bottom line, though, unless you know what to watch, you're going to suffer a cruel and horrible death at the hands of the performance counter gods. You don't want to be this guy laying in the morgue. There's definitely counters that are worth watching in your environment, and others that will probably be noise. Most of them will probably be noise for you, or they will only be useful in specialized situations. So before we get into the actual counters, let's talk about what you may need to do in your environment to facilitate better data capture. And I've got this covered in the reference, specifically the reference. And this is a common problem with Microsoft documentation. It's having trouble keeping up. It's called Monitoring and Maintaining SharePoint Server 2013. But in actuality, let me actually drag this over because it's kind of funny. So you can probably see that SharePoint Server 2013, but it targets SharePoint 2016. But it applies to SharePoint 2013. So as you can see, documentation is somewhat loose and fast at Microsoft. They're doing the best they can to keep up with a moving target. So I don't want to beat on them too hard because it is a tough job. I mean, these versions are moving very quickly. Now that we're in the cloud, for the most part, Microsoft with its cloud first strategy does everything in SharePoint Online before it ever comes to SharePoint on premises. So everything that's showing up in SharePoint on-prem has been tested by all your cloud friends who are living in SharePoint Online. In any case, that article, Monitoring and Maintaining SharePoint Server 2013, talks about configuring your environment for monitoring, and it calls out several things that you might want to do, the default setting as well as what it recommends. So things like turning off event log flooding protection. This is normally enabled to basically save you log space because when certain events start occurring or you start doing things like writing performance counters to the event logs or writing to the usage logs, what'll end up happening is that log can grow dramatically and it can grow very quickly. So, you'll have to determine whether or not the events you're trying to capture warrant turning off event log flooding protection, even for a while. You can reduce intervals on things like the SharePoint Foundation usage data import timer job. That's normally set to about 30 minutes. You can reduce that down quite a bit. Enable all diagnostic logging providers. Those are disabled by default, but you can turn them on. You can do things like lower schedule intervals for certain diagnostic job providers, things for the WFA web front ends and SQL Server. There are two different timer jobs for that. Stack tracing for content requests. This is often helpful when you're trying to locate and trace the source of a specific error through the call stack and through the event logs. Sometimes things that generate a correlation ID don't always show up in the logs, or log might be clipped saying that it got too many events at one time. These are things that we can do to help minimize that from happening, or prevent that from happening and minimize to the large extent. Turning on the developer dashboard, of course, it's not enabled by default. I like to set it to on demand so that we get the icon in the upper right-hand corner. And if that, if we need it, we can click that and the developer dashboard will pop open, as well as enable additional usage log data. So what should you be watching? Well, that's going to largely depend on the role of your server, as well as where you're seeing problems. Where we see problems in different servers depends on that server's role, unsurprisingly. So we can start with like web front ends. In web front ends, we're typically serving up pages through IIS, so we naturally want to do everything we can to keep that web front end pushing requests through the pipe. IIS and ASP.NET on top of it will track different counters around requests. These are incoming requests for things, both web services to the farm, trying to query data and write data, as well as page requests. So these are generic requests. So requests queued and requests rejected. I say requests queued should be low. The number will vary. It can, the point at which things really fall apart, I believe, is 5,000 by default. Ideally, you want to keep your queue length much lower than that, because what is happening is as those requests queue, they're going to sit there and wait so that they can be processed. If your number is growing in the queue, you're not keeping up with the incoming flow of traffic and you're on the verge of tipping over. So unless you're fighting just a temporary spike where the queue length goes up, If your queue length goes up and keeps going up, you're in a world of hurt. And it's time to add more web front-end capacity. Likewise, you should never see ASP.NET requests getting rejected. That should be 0. Wait time should be near 0. There will always be some fluctuation with wait time. It tends to hover at and around 0. You might see occasionally, it jump up into double-digit milliseconds in terms of wait time. And this can be correlated on the other end of the pipe by somebody in their browser using the SPIIS latency response header, which we'll talk about in a little bit. But you want to see that near 0. Likewise, your worker process should not be restarting out from under you. Now, the worker process will restart if it starts to grow and the automatic restart mechanism determines that it's unhealthy. Worker process restarts at roughly 35 to 40%, I think, memory utilization by default. When your worker process grows above that level, IIS is going to take a look at it and say, hey, we got to restart this. And so it'll drain stop requests to the worker process and spin up a new one at the same time. Well, while it's spinning up a new worker process, that is going to limit the ability of that web front end to service requests. So unless you have additional capacity, and this is where load balanced environments come in handy, you're not going to be able to sustain any level of additional traffic through your remaining web front ends if you don't have capacity. So we naturally don't want to see restarts happening outside of planned times if we, in fact, restart them at all. Web front ends also use their memory for caching to accelerate web requests. This is one of the great uses of web front ends. SharePoint provides several different cache types. 2 of the 3 that I'm thinking of are based in memory. Those are the object cache and the output cache, which piggybacks, SharePoint's output cache piggybacks on ASP.NET's output cache almost directly. Another memory-based cache is the distributed cache. That functions somewhat differently to these mechanisms. We also have another cache that's based on disk, and that's the blob cache. And I'll talk about that again in a minute. But ASP.NET applications cache API trims and the cache API hit ratio. So we shouldn't be trimming the cache very often. That should be near 0, and our API hit ratio should remain high because naturally we want as much content as possible to be served out of the cache, so we're not doing real-time fetches from databases or other services. Now, a few other numbers worth pointing out. The publishing cache also has what are called total number of cache compactions. That's specific to the object cache. Now, this is an interesting counter. I have firsthand experience with this, and I actually link my I linked to a reference in my blog. But back in the MOS 2007 days, those of you who can remember back to that point, the total number of cache compactions at that point was a relatively unknown number. And the only guidance that was published was based on the cache hit ratio. So the cache hit ratio is an interesting number. And it's, ideally we're up in the high 99% if we're serving the bulk of our content out of the cache. There's a dirty secret about the cache hit ratio and several of the other numbers here in that they don't reset until a server is rebooted. So if you have a server up and running, let's say for a full month, and it's maintaining good cache hit ratios, and we go on to day 31. So for 30 days, we've got good cache hit ratios. Day 31, let's say we make a memory change, and this is an admission of guilt on my part. I did something very horrible in a former life, and I'm still paying the price for doing that. I'm on work release. I have to give these talks every now and then, and they let me stay free. But I was in an environment where I reduced the object cache quite dramatically. And I'm not going to say exactly how much, but if you read the post, you'll find out how much I reduced it. Well, that cache hit ratio continued to stay high, because on day 31, even though I was getting very few hits in the cache, when you take 1 day of bad results and divide that by 31 days, 30 of which are good results, you're still in the 90s. In fact, you're still in the mid to high 90s if you have a 1 day where you are not hitting the cache. So the cache hit ratio did not become a good counter to use for checking instantaneous memory changes. What we ended up using was the number of cache compactions, and that should be near 0. At the time, it was determined that anywhere under 2 per hour, you're doing fine from a memory perspective. When you hit 2 to 6 cache compactions per hour, you're starting to run into some gray area that probably shouldn't be happening. If you're doing more than 6 cache compactions per hour, your object cache is starved for memory. You really need to allocate more memory to it. So it's a little bit of insight into some of these values. And then finally, we talked about blob caching a little bit. The blob cache maintains a percentage full hit or percentage full performance counter, which is really just telling us how much space we've got in the blob cache, or rather how much use we're making of the blob cache on disk. Now, when that blob cache is getting towards 80 or 90% utilization, it might be time to do 2 things. One is, if we know that more stuff could end up in the blob cache, we might need to allocate more disk room. If we're uncertain, it's definitely time to review what we've got our settings at and to make sure that we've got disk space. I've worked in a couple of different positions where I have seen the blob cache not changed from its default. So by default, the blob cache is ending up on it ends up on the C drive, and if administrators unknowingly simply turn that on, what it's going to start doing is filling the system drive up with blob assets, basically binary large objects. Most admins I know don't like to see their C drives filled up with random cache data. And I've seen several scenarios where it's played out that the system drive was run out of space and the server would no longer boot. So you want to make sure that you get the blob cache off onto its own drive, but then maintain some monitoring and maintain some headroom so that you can grow if you need to. Now, when we get to application servers, specifically, different application servers serve different roles, and we don't have enough time today to cover all of the various roles that those servers are in. So, distributed cache, BDC, search certainly has many different counters. What I did here is just provide what Microsoft has said are good counters to watch generically for servers. So things like the processor time, anything above 75 to 85% utilization is bad. We want to have at least minimum 20% headroom on various SharePoint servers. Likewise with memory, we don't want to be hard paging, pages per second. If we're paging out to disk more than 10 pages per second, that's indicative of a problem with memory. We need more memory in the server. Likewise, a hard limit of 2 gigabytes or less. When you are running that low on memory on the server, the operating system doesn't have enough space to do what it needs to do as well. Disk queue lengths, well, those are going to depend. That depends on so many different things. I specifically got an article in the references that talk about disk queue length and how to keep that low. Disk queue length depends on so many different factors: the type of storage we're using, disk controllers, how many threads and cores we've got running. We can't do anything in terms of guidance that's formal without acknowledging those different things and the role they play in storage. But we can talk about things like idle time and free space. Naturally, we want our disks to be utilized. If you're at less than 90% idle time, you're probably you're probably running a little too hard. Less than 30% free space is also bad. Time to start looking at adding more storage or growing your LUNs. Now, these settings are also, I didn't call them out for the WFEs, but they're valid for the WFEs as well. And so, commonly WFEs, if we're doing okay with caching and we're doing okay with our ASP.NET pipeline turning requests around satisfactorily, then we might still run into problems where processor is being utilized too much. And this is not an uncommon situation when developers end up writing full trust solution code that ends up installed in the farm in the form of a solution package. I know in a high throughput environment I worked in previously, a developer had lifted some code that I had written for some central admin pages and put it into play on the main site. It was never intended for that type of environment. It was it was using reflection significantly. The reflection APIs are known to be very top heavy, chew up a lot of cycles. So when this code was pushed out and put live, suddenly our processor utilization on the web front ends went from roughly 20% to roughly 50%. Now, of course, that's not hitting the danger zone just yet, but when I see a 30% processor jump on web front ends, that tells me something just happened. And so we had to back that code out and rewrite it. So things like processor time are good to monitor as well as memory. Now, finally, SQL Server. There are tons and tons of SQL Server counters to pay attention to. You will find different lists based on people's area of expertise. I will freely admit I am not a SQL Server monitoring expert. Anytime I've worked with SQL Server, I knew certain things to watch. I cared about, number of connections to the database, how often those reset. I cared about deadlocks, wait time, things like that. But this is a set of SQL Server counters that was put together by Microsoft, and specifically I have an article calling out SQL Server guidance that towards the tail end of it mentions a handful of monitoring counters to be monitored, both before you have problems and then after. So many of these don't actually provide some immediate benefit if you just go in and look at your SQL Server, but they're really good to have to establish a baseline and then come back to when you're encountering a problem to see if SQL Server is involved in it. But the bottom line is performance troubleshooting is an art, not a science. I wish it were more prescriptive, but there is no prescriptive path to cover every situation. I tell people plan to spend some time noodling. SharePoint monitoring, I know when I first started doing it, I had to do it for a while just to learn to understand what was happening and what was moving, to understand what different changes in performance counters were and how those would manifest in the environment. So get yourself, if you don't have the time to spend noodling and looking at this proactively, you may want to invest in something like a tool that has some of that intelligence, like I said, built in for you. So with a little bit of time that I've got left before we turn it back over to Sylvia, I want to talk about page performance monitoring because thus far we've been looking at the server side of the equation, and performance monitoring from the server side, that's only one half of the overall equation when you take end-to-end performance into consideration. To fully understand and to, I guess, visualize performance and to understand how it's being felt, we need to put ourselves in the roles of end users to monitor and diagnose a number of other issues, specifically page performance issues. And, what is it that we can do from the other end of the wire? Is there something we can do to troubleshoot performance after data has left the server, or in addition to what we're doing on the server side? The answer is yes, we can. There's quite a bit that we can do. And believe it or not, your browser is an amazingly capable performance tool if you understand how to use it. Every modern browser nowadays comes with tools built into it. And these are the magic F12 debugging tools. And pretty much every browser. I typically use Google Chrome, IE, and Edge. If you hit F12 and go to the Network tab, what you'll get is a trace that looks very similar to what you would get when monitoring with Fiddler. And for those of you who aren't familiar with Fiddler, Fiddler is I mentioned it earlier, and I've got a link to it in the references, but Fiddler is a transparent web proxy that when you launch it on your system, it inserts itself between your browser and your web destinations so that all traffic runs through Fiddler on the way out of your machine and all responses run through Fiddler on the way back in. So in essence, what Fiddler does is it captures everything going out and everything coming in, and it correlates it so that it can provide you with requests that are being made, data being returned, how much data that is, how much time it takes for requests to traverse out to servers and come back. It's very useful. The reason I'm talking about using a browser debugger rather than Fiddler explicitly is because browser-based dev tools and network monitors have one great advantage over Fiddler, and that's that they inherently handle SSL traffic. So anytime we're going to SharePoint Online for sure, and many of us on premises, we're going to go through an SSL tunnel. And SSL encrypts traffic so that if we want Fiddler to debug that, we have to go through a bit of non-trivial configuration to trust certificates and enable Fiddler to look inside that SSL tunnel. The browser debugging tools do it natively, so we don't have to worry about SSL. So that's why I'm focusing on browser-based tools here. So what we can get out of that, that traffic going back and forth is things like, HTML that's returned, HTTP headers, response codes, cookies, all sorts of things that that we might want to look at. So there are several page performance response headers that will be returned by the SharePoint server when we visit it. There are three in particular that I want to focus on. The first is the X SharePoint Health Score. Now, this is a measure of the server's, of the web front end in particular's general load or stress. Values range from 0 to 10. So when that X SharePoint Health Score comes back, what we want to see is 0 or close to 0. Anything that starts to go up and particularly approach 10 means that the server is being stressed pretty heavily. And we may have a capacity issue. It may be transient, but it may indicate a capacity issue, because once that number starts to approach 10, the SharePoint server, the web front end, is going to start shutting down different processes that it deems are low priority. Now, timer jobs, various search crawls, other things like that might be identified to the server as low priority. And when they are, they will be selectively suspended until the server gets back to a point where it's not being stressed anymore, and that X SharePoint Health Score goes down. So this is a general indication of what the environment's like on the server side when we're hitting it. The next number, and this is a very important one, the SP request duration. This is the amount of time our request spends processing on the server, and it's measured in milliseconds. Now, SharePoint sometimes returns requests quickly, sometimes returns requests after some time processing. Ideally, we want to see less than 3 seconds, 3,000 milliseconds. That's more based on users being unable to tolerate any amount of time much greater than that. I've got a couple of studies that I linked in the references about users actually on e-commerce sites and other types of sites. If it gets to be more than 2 or 3 seconds, they're going to abandon the request. So 3 seconds tends to be pretty much the top end of where we can expect to keep users. Now, if our request is taking longer than that on the SharePoint server itself, we've probably got something going on SharePoint, in SharePoint, that is ugly. Either that or the server is under heavy stress. The final number we want to look at is the SPIIS latency. which is the amount of time that the request spends waiting or queued up. Now, you remember me talking about the wait time, the ASP.NET wait time. That should correlate roughly to SPIIS latency for any given request. Now, we want this to be near zero, and the highest I've ever seen it under normal operating circumstances is in low double digits milliseconds, maybe 17 milliseconds. We don't want requests sitting around for any period of time on the server, because requests, when they start to sit around, they're going to start to back up. And so our ASP.NET request queue on the server side is going to start to go up. So when IIS latency increases, as evidenced on the client side, that's a good sign that if we were to go look at the server, we're going to start to see queue lengths increase, and we do not want queue lengths to increase. So this should be near zero under normal operating circumstances. So when we take some of these numbers and start to put them together, we can start to infer, or at least try to diagnose from the client side, where we're running into problems. So if I take a look at that network trace and take a look at the round trip time as reported by my browser, and I subtract from that the sum of the SP request duration and the SPIIS latency. So the request duration and the IIS latency, when you add them together, you've got the amount of time that the request more or less spends sitting on the server. Whether it's being processed or it's being waited on, it's sitting on the server. If you take that time away from the total round trip time, what you've got left is time that's lost elsewhere. So consider, for instance, this trace. And let me actually zoom it here so you can see these numbers where I'm pulling them from. So my request time total, 76.04 milliseconds, and I'm pulling from my response headers the IIS latency of 0 and the SharePoint request duration of 51 milliseconds. That's the amount of time it spent operating on the server. When I take those and run them through this equation, 51 plus 0 from 76 milliseconds leaves me 25 milliseconds of time spent elsewhere. For people in SharePoint Online, they would drool for numbers like these. But this is one of the benefits of operating within an on-premises environment in a data center that's well-tuned. In fact, I want to level set appropriately. This is a high-performance SharePoint farm that's not under load at this point. May not reflect real-world conditions. So just to level set appropriately, but if you've got a well-tuned farm and it's doing what it's supposed to, you should see sub 100 millisecond latencies and little time spent on the network. But the reality is sometimes we're not going to have numbers like this. But first, now I want to point out, I went and decided to do some searching, because when I originally wrote an article that I referenced in the references for this, for these exercises that I do about performance troubleshooting, I was doing it for SharePoint Online. I wasn't sure though how far back these these response headers actually lived in SharePoint, that they would be available on premises. So I found out that this does work for SharePoint 2013 on-prem as well as SharePoint 2016 on-prem. I booted 2 different VM environments I have and went looking for those response headers. And I got them back from 2016 and 2013. I don't know that they were available as far back as SharePoint 2010, but for those of you with a modern version of SharePoint, going back to 2013, you should be able to get these headers off of your SharePoint on-premises environment and be able to use them for diagnostics. So common outcomes, when I've gotten consistently high SP request duration values, now there are many different things that can cause these high request duration values. But when I see request duration values going up into the thousands of milliseconds, oftentimes if you've got server-side code running where developers have written code and installed it into your environment, it might be time to start looking at some of those different different solution packages that they had installed. Questionable development practices, this is one of the main reasons we went to the new, and it's not new anymore, but the app model in SharePoint 2013, which has become the add-in model for SharePoint 2016 and beyond. It's to get running code off of the servers. If we need to customize, we need to move that code off to proper application servers. So consider what developers might have done. It may also be related, you may not have any server-side code running, but you may have other load in effect. Now, every web part that's placed on a SharePoint page incurs additional processing time on the server side. So if you place enough web parts, or you place the wrong web parts together, things like doing XSLT transfers or transforms of large XML files as done by the XSL web part, you can actually run your server load up dramatically as well. So you need to look at your request duration values, try to determine where they're coming from, whether it's user code, whether it's developer code, web parts on the page. There's probably something happening to drive that number up. Now, if your SharePoint health score is also high at the time, this is probably a transient condition, tends not to lead to consistently high durations. But if your SharePoint health score is high at the same time, the server was probably under stress at the time, and that may explain your values. Now, the other factor you might have in play is seeing a lot of time lost elsewhere. So if you compute that equation that I gave you, where you take the time that the request took to go to the server and come back, and you subtract out your request duration and IIS latency values, and you're still left with a very high number, like hundreds, even thousands of milliseconds, there's typically something else going on. Oftentimes, this is indicative of problems with your network or network congestion, because we're looking at time lost in latency. Might be routing related. Anytime you've got network load, this can dramatically increase the amount of time it takes to get to SharePoint and come back. There are other factors which can come into play too. You might be getting routed through a web proxy, and if that web proxy is overloaded or needs to do authentication, if that sits between you and SharePoint, that can introduce latency. If you are in an issue where you're trying to do some DNS resolution and DNS isn't responding properly or is being routed all over the place, DNS resolution issues will also make it look like the server's taking a long time to respond, but when in fact you're doing DNS lookups. This can be figured out adding in something like Wireshark to separate your different traffic by protocol. And if you look at your DNS and you see that's taken a long time, but SharePoint's not actually taking a long time, you can ascertain the actual reason behind the long delays there. But of course, that forces you to get down to lower level troubleshooting. Wireshark, if you're not a network troubleshooter or you have no experience network troubleshooting, Wireshark can seem daunting at first, but it is a tool that can be used to help troubleshoot these issues. So with that, I turn this back over to you, Silvio. I think I'm doing pretty well on time.
Oh, yes, you're doing, and it was a great presentation, Sean.
Thanks.
Yeah, okay, so can you switch the controls to me so we can proceed?
Sure.
No problem.
Let's see. Should be coming back over to you.
It's not happening. Perhaps I can request it.
There you go. There you go.
Oh, okay. Just give me a second. Okay, are you seeing my screen normally? Well, where I left off?
Yeah.
Yeah. Okay, great. So once again, thank you for the presentation. Right, we'll get back to you in the Q&A session. And now I believe everyone has learned something new, and it's time for us to quickly introduce SysKit Monitor to you. SysKit Monitor is a server monitoring and administration tool which is designed to help system administrators and consultants in their daily tasks. So with SysKit, you can monitor user activity, application usage, server performance, you can track server inventory, you can generate documentation, you can basically monitor everything that's happening in your environment on your servers. And besides environment monitoring, it also helps you with remote server management tasks. And it does that with the help of integrated PowerShell GUI that will enable you to execute multiple scripts on multiple servers with just a few clicks. And another important fact is that SysKit Monitor is an agentless tool, meaning you can monitor and manage all your servers from one central console. There's also a SysKit web application available, and what it enables you is simply to reach your monitoring data from, well, practically anywhere. All you need is a browser and some internet connection. In today's demo, I'm going to show you how performance monitoring with SysKit actually works. Now I'm going to switch to my environment. Okay, are you seeing my demo environment, Sean?
Yeah, I am.
Yeah, okay, great. So here is, well, our demo environment, and what I'm gonna do is guide you through the performance reports which you can use to monitor your SharePoint servers. So for start, I'm gonna tell you what exactly is SysKit monitoring on your server. So I'm gonna go to administration, and then under monitoring templates here. And now what we see here is a list with some names and some servers around. And perhaps I should start explaining you the basic principles with the default template. So each of these templates, included this default one, includes a couple of performance counters that are being monitored, and each of these performance counters has an warning threshold and critical threshold attached to it. So in case anything happens, let's say a value of a specific performance counter goes over or under the value, you can tell SysKit to send you an alert. So we have, well, kind of 2 degrees here. So we have warning when SysKit is telling you like, oh, you should take a look at this, something could go wrong. And you have a critical alert when SysKit is telling you, okay, something is definitely wrong. And for each template, so this is a default template, and this template is assigned to all of the servers, so all the server types you have in your environment. And as you can see, those are some basic straightforward performance counters. But in your environment, you're probably gonna have a different server roles. So in your SharePoint environment, you're gonna have these different server roles, and not to talk about the global environment. So what we do here is we provide you with some more specific monitoring templates, like let's say this one for SQL. And as you can see here, this SQL server is applied to this computer. So not all computers, but only the SQL computers. So we can do it for each server, each template we want. So in case you've added another SQL server to your environment, you can simply go assign to computers, select your server you wish to monitor, well, that has a corresponding role to that monitoring template, and simply add it there. And as you can see, so all of those servers will have this SQL specific performance monitoring template, the performance counters monitored, and this SQL specific services monitored. So that's pretty much the basic principle of it. So you can create multiple specific monitoring templates and apply them to specific servers or server groups. So you don't have to kind of monitor all the performance counters on all the servers, because you'll have a big logs and you'll get lost easily. Some of these templates come out of the box. We also have some on our in our network. So this is something you can download, and this is, well, something we recommend you to monitor. But as Deshaun said in his presentation, you have hundreds and hundreds of performance counters, and you need to know what you're looking to monitor. What you can do is you can easily edit any of these templates that come out of the box with a tool. But what you can do, and what you probably do, is you can create a new template. So let's do it like we just go to add, and let's say we are looking to do to create a template for our web front-end servers. So you can write in some kind of a description, and then you go next. And this is where, from your environment, you will have, let's say, 1 or 2 or 3, or I don't know how many WFS servers, but it is important that you load the performance counters from the server that corresponds that role you are looking to monitor with this monitoring template. So you simply click load. And then what you're actually doing here is, well, what Sean mentioned, you're kind of trying to talk with the gods of performance counters, because SysKit monitor will load like thousands of them. And this is the part when it would be great if you consult with Microsoft documents or simply Sean's presentation to see which specific performance counters are you looking to monitor, and what threshold and critical values are you looking to set for that for that specific monitoring template. This takes, well, a bit of a time, but we'll give it a wait, of course. Okay, so as you can see here, we have SysKit monitor has loaded like thousands and thousands of, I mean, not thousands of thousands, perhaps I'm exaggerating, but a lot of performance counters, and some are SharePoint specific. And I'm just gonna, well, select something that is kind of out of the blue to show you how would the adding of monitoring template work. So let's say you're interested in this counter. Of course, you can add many counters here to this. So I'm just adding one to show you how it works. And then we go next, and then we can, for each of these counters we've added, you can set up specific warning threshold and critical threshold. I mean, we can set it this way. And so basically, now once you create this template and apply it to a specific SharePoint server, whenever this value of blob cache flushes per second goes above number of 10 or above 20, you will receive an alert. So this is pretty much as simple as it gets. The same thing goes for the adding up the services. So there's a list of all the loaded services, and you can simply select any, let's say, SharePoint service you wish to monitor, and again, add it to your monitoring template. And now what we have here is a monitoring template we just created, well, from nothing. And what we should do next is assign to computers. And I don't know, we would assign it probably this one. And then you'd have a specific monitoring template that would monitor specific performance counters for this server. Now, what I'm going to show you is how would that work in real life. Now, I mean, this is pretty much just for show, the whole demo environment and everything, but we would go to the performance reports right here. And this is where we have kind of a system overview. So this is showing us top computers by CPU, top computers by memory, top computers by disk space. And what is also showing us is kind of today's alert screen. Now this is great. So remember when I told you that whenever the performance counter goes over a specific threshold value, it will generate an alert. So on this screen, you can simply drill down and you can see all the alerts. So all the warning thresholds or critical thresholds or stopped services that happened within your environment. So let's say this is for today. What we can do, we can simply go back to last 30 days and we can see everything that's been happening on our servers in the last 30 days. But let's keep it in real time. And what we have here is kind of a chart that is telling us about all the servers we have in our environment. And we can see that some of the servers are healthy, some are in the critical condition, and some are in the warning condition. So what we do is we drill down here, and this is taking us to another dashboard that this is giving us a bit more information about our servers. And let's say that we're interested in, well, what's happening on this server right here. And again, what we do is simply double click and we drill down, and we're brought down to the single computer overview screen. So these metrics you see here are the ones included in the default template I talked about. And we would also have additional the additional performance counters shown here in case this server SysKit was assigned to any other performance template. In this case, it is not, and it is red because it's, well, pretty much running out of memory. As you can see, this is red. This is telling you something is wrong. You can also click on this to see, well, what's been going on, and you can see, wow, there is some serious spike in memory usage in the last 2 hours. I should probably do something about it. Now let's get back to our dashboard to show you that on a more specific case. So let's do that for our beloved SP1, which is a SharePoint server, and we see that he is not, well, critical, but he has a warning status. So again, we're interested in what's going on here. So we pretty much double click on it, and we can see that all of the default and basic performance counters are okay, and everything is okay with the IIS performance counters because it has 2 monitoring templates applied to itself. But there is something wrong with the SharePoint part of this server, and what we can do here is we can drill down, and we can see that our current problem is counter, which is showing us pages per second. And again, we can open that counter, and we can see what's been happening with that counter on that server in, let's say, last 24 hours. And now if we're not sure that this is something that is happening, well, usually, so let's say you just start monitoring servers and you don't really know your baseline, what you can do is you can use a server that's supposed to be the same. So let's say these 2 servers have the same configuration. Let's say one is production, the second is the test. And what we do is simply compare them both on the single graph. And now we can see that it is not normal. So what we're seeing on the SP1 is not normal because it is a lot bigger value than what we're seeing on the server that is supposed to have the same value. The same thing goes for, let's say, services when they stop. So let's say we can select an SQL server, and again, we simply drill down, see everything is okay here. It is not okay regarding the SQL. It is okay regarding the performance counters, but what we can see here is that our SQL Server Agent service has stopped, and this is something that should be looked at. So basically what we did here is we went from one system overview that is telling us, look, you have something wrong, to exact performance counter that went wrong and why it went wrong. So that's pretty much how you would drill down and detect the performance problems. So another great thing what you can do is that you can monitor performance values for each process on each server. So let's say we want to filter out the IIS worker process, or as you might know it, the W3 WP process. It is the essential process for IIS. So each application pool creates at least one instance of W3 WP exec process, and that is what actually processes requests in your application. So this way you can simply, so I'm gonna filter it out now. Okay, let's say, okay, select this one. And now okay, I'm sorry, I need to select all the servers to see the complete data. Okay, so now I see all the IIS worker processes started on all computers by all the users, and I can simply see which one of them is pointing out, well, there is something wrong with here. He's using a lot of memory, and you can, I mean, they all have the same name, but you can easily differentiate them by the PID. And that would be all for our today's demo regarding the SysKit monitor. What I could also mention, but I don't really have time to show you now, is Sean was talking about page performance monitoring. And this is something that SysKit can help you with the PowerShell GUI I spoke about. Because what you can do, well, let me give you an example. So what you can do is you can create a PowerShell script that would ping all of your SharePoint sites and return back the value that the site returned and the time it takes the site to load. So what you would tell SysKit to do is basically each 5 minutes you would ping all of 100 SharePoint sites, and once it returns every value that is different than 200, so the 200 is code for everything is okay, or let's say if it returns value that the load time was longer than, I don't know, 15 seconds, then you would receive an alert. And okay, so that would be it. We can get back to you, Sean, and to the Q&A questions. Are you here?
Yes.
Yeah, okay,
I
let me
believe I
just...
answered all the ones that I could answer.
Okay, just give me a second, I'm sorry. Having some mild... Okay, can you see my screen now?
Mm-hmm.
I have a bit of a delay in switching from my demo environment to my presentation. Okay, so it's time for the Q&A session, and now we're going to read and answer the questions you asked during the webinar. So, Sean, start when you're up to.
Okay, there were quite a few questions about the book. The link for that, I supplied that in the chat, or at least I sent it out to all. Someone asked about monitoring, what we could do to monitor Office 365. Unfortunately, Office 365 is something of a black box for a lot of monitoring. Now that's changing. Microsoft is trying to add extensibility points so that we can start to tap into normally internal API information. That's coming here and there, but there's nothing formal around that, at least yet that I've seen. Of course, the fact that I haven't seen it doesn't mean that it's not out there. Things move very quickly, but traditionally, you won't be able to do traditional performance monitoring on Office 365 because it's just not something that's exposed. So these tools that provide very rich interfaces and understanding into the underlying platform unfortunately don't have a home out there. So a lot of the troubleshooting that we do has to be done indirectly through things like response headers that are supplied by the server and whatnot. There was a question about the baseline performance data that's supplied. The Microsoft Assessment and Planning Tool. Honestly, I'd never used that prior to the question about it. It looks interesting. I guess it's something for me to research, but hopefully that the fact that I haven't used it maybe provides some insight into whether or not I recommend collecting the baseline performance data. Anytime I've collected baseline performance data using out-of-the-box tools, I've set up a performance monitor session to monitor over a period of 24 or 48 hours, and then I crunch that data offline. So I've never actually used any other more complex tool. I've worked several places where they've had third-party tools, like SysKit. They naturally provide a bridge into that space and make it easier to collect that data and make it easier to target the things I care about. SysKit, of course, can email you those sort of performance counters and summary data, which is nice. But Perfmon, it's you get what you pay for, and since it's free and out of the box, you pretty much are working with the bare minimum. Let's see. They're asking about the recording being available. I assume that will be available later on. I'll also post these slides on my blog, which is sharepointinterface.com. I have a resources section where I always put things out there. So if you Google my name in SharePoint, you'll hit my blog. There's more coming in. Have you ever built a... So there's a question about using Visual Studio to build load tests. Typically, load testing has been the purview of someone besides me. I've not actually worked with any tools like Visual Studio Load Test or Mercury Load Runner. I've always had somebody else in that role. I've helped guide them on test creation, but actual load testing of the site, I've not actually been involved in. Just looking at the effects on the back end.
SP request time covers everything from network to storage, etc. Do I have a recommendation on how to find a bottleneck in a highly splattered environment in terms of different teams being responsible for different infrastructure topics? That's a good question. I've worked in environments where the different the teams, first of all, the infrastructure teams, it wasn't one large monolithic organization. It was pretty much done in silos. So the Windows Server team was different from the network team, was different from the firewall team, was different from the database team. Unfortunately, as a SharePoint professional, you're often the hub of communications in situations like that. So in those sorts of organizations where the SharePoint specialized knowledge was being held by me, I unfortunately had to lead most of the troubleshooting efforts. And what that often involved was me getting in a room with a representative from all the other teams in kind of a war room fashion. We all had our tools up. I was looking at different facets of the SharePoint environment, seeing what the performance counters told me or what they indicated, and had to go back to, hey, firewall team, do you have ports closed that we need open? I'm not seeing any traffic traversing on TCP port 335, or we're seeing long delays in requests for the servers. Are we seeing connection handles being held open by SQL Server? It was any host of things. It's unfortunately, yeah, everything's only customers' faces red. Yeah, I know what you mean. It's the people that have to work those issues in those organizations until they develop a cross silo team that's focused on SharePoint. And these are typically some of the higher performing people who have greater knowledge and can speak to the many different concerns. In those sorts of situations, you can sometimes, you can put the team together, but eventually the team, if you don't have that, the SharePoint professional has to be the person with the knowledge to organize the teams. And I'm sorry to have to say that, but that's the way we operated for a long time until the SharePoint teams, the special people who were brought together just to troubleshoot SharePoint could be brought online. And that was, unfortunately, it took like 6 months for that to happen. So experience blob cache, SSD, and separate disks. Putting blob cache and SSD on separate disks. I don't have any real experience with the blob cache on SSDs. Back when I was doing most of my troubleshooting, unfortunately, SSDs were not cost effective for organizations to use. I know that's changing. SSDs are pretty much something of a universal equalizer these days, and the storage is getting cheap enough that they can become a reality. I don't have any data or anything to share on that. I'm sorry. So yes, the presentation will be out on PDF. Yeah, sorry, Daniel, no magic tricks. I think that covers, there were a couple questions, Silvio, I think regarding SysKit, what it can do. I know there was a question regarding could it reach into SharePoint Online? I'm pretty sure the answer is to no to that.
No, we are taking the data out of VMIs, so no,
Yeah.
we're not doing that online.
Okay.
I mean, all of the questions that are not answered, well, here we'll try to answer them over email, especially the questions, regarding the SysKit monitor. I'll personally answer to, well, each person who has a question.
Okay, and if anything else comes out that, is more specific to the topic, if I can take a crack at it, feel free to send me an email. I'm Sean at bitstreamfoundry.com. I think I've got a contact slide towards the end. I don't know if you have those integrated into your deck, Silvio, but
okay, great. No problem.
References.
People will definitely appreciate your view on the whole problematic.
Okay.
Did you find any other questions you'd like to answer now, or?
No, there's just a couple of things trickling, and sp.kit being related to SysKit, is it? That's about it.
Okay. Then, I guess we can pretty much end this webinar. Unfortunately, well, we didn't answer all the questions, but I'm sure that Sean answered all of them that were, well, kind of burning up. And Sean, thanks you once again for the great presentation. And is there something else you'd like to say to our attendees, perhaps?
No, just I was really happy to be able to provide this today. I love the folks over at SysKit. I've had a very long relationship with them. They're a great group of people. They make great tools, and thanks for giving me the chance to present another topic. I hope we can do it again in the future.
Yeah, I hope we should definitely do that. Well, this was definitely a great presentation. I mean, I enjoyed it, and I believe, well, all of our attendees enjoyed it here.
Yeah,
so
thanks to you folks.
Okay, thank you guys for joining, and well, take care. See you another time.
Take care.